हेलो स्टूडेंट्स, हाउ आर यू। होपफुली बहुत अच्छे होंगे। बेटा देखिए, अभी इससे प्रीवियस वीडियो में मैंने डिस्कशन किया इंट्रोडक्शन क्लासिफिकेशन कि क्लासिफिकेशन ऑफ एलिमेंट क्या है और उसकी ज़रूरत क्यों पड़ी। ठीक है, और इस डायरेक्शन में जो नंबर ऑफ साइंटिस्ट हुए जिन्होंने अपने अलग अलग व्यूज़ दिए क्लासिफिकेशन के, उनमें से फर्स्ट है डोबेर्नियर्स लॉ ऑफ ट्रायड। डोबेर्नियर is a German chemist in 1817. Doeberneir started to arrange the group of three elements. Okay, group of three elements which have similar properties. Actually, he grouped the three elements either having same atomic masses, nearly same atomic masses, or the atomic mass of the middle element. He arranged in such a way that atomic mass of the middle element was the arithmetic mean of the masses of other two, like this. And then he observed that, Doeberneir observed that when he arranged the elements in the group of three, triad means group of three. Okay, group of three, their atomic weights in the group of three, he found that their atomic weights were either nearly the same or the atomic weights of the middle elements is arithmetic mean of other two approx. Doeberneir, name of scientist. He started the group of three elements either having almost the same atomic masses, or the atomic mass of the middle element is nearly the arithmetic mean of other two, and you observe that all these three elements have almost similar properties. For example, when he arranged iron, cobalt, nickel, all these have same atomic masses, their properties are also almost same. Lithium, sodium, potassium, the atomic mass of the potassium middle element is the arithmetic mean of the other two. It is all these three have the same characteristics. As you know, these are the alkali metals. Similarly, calcium, strontium and barium, the atomic mass of strontium is approx arithmetic mean that of the calcium and barium. And similarly, we talk about bromine, its atomic mass is nearly the same that of the arithmetic mass of the chlorine and iodine, and all these three have the same characteristics. So Doeberneir, it was the basically first attempt for the classify elements. So this is the view of the Doeberneir's triad, but he failed to classify all those elements which are present at that time in 1817. Nearly 65 elements were discovered at that time, but he failed to classify all these elements in form of triads, so has been discarded. And then later on, Newlands law of octave has come in existence. Newlands is a German chemist, it's an English chemist, British. He arranged lighter elements basically, not for heavier elements. Newlands arranged lighter elements basically in order of their increasing atomic masses. This is the first periodic classification. Newlands started to arrange the increasing order of atomic weights of the elements and found that every eighth element have almost similar their chemical and physical properties as that of the first one. Just like in the musical notes, there are 7 musical notes, sa, re, ga, ma, pa, da, ni, then sa, and you observe that with very similarities. Just like in musical notes, 8th musical note is the same as that of the first one. Similarly, when you started to arrange elements in their increasing order of atomic masses, lithium, sa, re, ga, ma, pa, da, ni, he started arranging lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and the 8th element is the sodium, which have the same characteristics as that of the lithium. Similarly, magnesium has same characteristic as that of the beryllium. Aluminium has the same characteristic as that of the boron. So this is the Newlands octave law, but it was unable to classify heavier elements. Calcium, the 40 atomic mass. After the 40 atomic masses, when we arrange the elements further, then we observe that their properties, characteristics are not properly matched. So this one is applicable only for lighter elements, and this one is applicable only for some limited elements. These are the 4 triads I made earlier. 2 और 3 ट्राइड्स और है इसके अलावा, बट सभी एलिमेंट्स के ना तो ट्राइड्स बनाए जा सके, ना सभी एलिमेंट्स को इसके अकॉर्डिंगली क्लासीफाई करा जा सका। सो ये भी फेल्ड हो गया और ये भी फेल्ड हो गया। वैसे एक बीच में 1862 में 65 से ठीक पहले एक साइंटिस्ट थे A.E.B. Chen Cortius. A.E.B. Chen Cortius gave the very different and unique pattern of classification that you can say it's a first 3D classification. He took a cylindrical shape, and 18 vertical column lines are drawn on the cylindrical wall, and just like a helix, he started to join these lines and observe that when elements are arranged from the starting in the increasing order of atomic weight, then he found that the elements which have the same characteristics lie in the same column. But कोई proper justification नहीं था why we took cylinder and why 16 vertical columns were taken. साइंटिस्टों ने गैस किया कि शायद ऑक्सीजन उस टाइम पे एज ए रेफरेंस एटॉमिक मास होता था, इट्स अ डेफिनेशन ऑफ 1 एटॉमिक मास यूनिट, शायद इन्होंने इसलिए 16 मास लिया होगा। तो इनके बीच में एक और भी आया था जो बिल्कुल भी उसकी सिग्निफिकेंस नहीं है, बट जस्ट ओनली फॉर योर नॉलेज, A.E.B. Chen Cortius in 1862 gives telluric screw law, but it has been discarded. This is the first 3D attempt of the classification. He took a cylinder, and this cylinder is divided into 16 vertical columns. If you made 16 lines, and then he observed that when elements are arranged in the helical or screw or telluric path, then the elements having same characteristics would lie in the same column. But this classification has no significance, और इसमें साइंटिस्टों का बहुत ज़्यादा ध्यान भी नहीं खींचा। ये आया था 1862 में, तो ये भी डिस्कार्ड हो गया, ये भी डिस्कार्ड हो गया और ये भी डिस्कार्ड हो गया। इसके बाद की स्टडी बेटा बहुत ही इम्पोर्टेंट है और हमने वही आगे कंटिन्यू करनी है। ये तो हिस्ट्री का पार्ट था, ठीक है। इसके आगे की जो स्टडी है वो मेंडलीफ ने की। मेंडलीफ के साथ साथ एक लूथर-मेयर कर्व है, वेरी इंपॉर्टेंट, और फिर मेंडलीफ की टेबल के डिफेक्ट्स, सिग्निफिकेंस, फर्दर मॉडिफिकेशन, मॉडर्न पीरियोडिक टेबल एंड द जो बाद में अभी आप पढ़ रहे हो लॉन्ग फॉर्म ऑफ द पीरियोडिक टेबल, दैट इज वेरी इंपॉर्टेंट। सो आई विल सेंड यू द नेक्स्ट वीडियो, एंड दिस इज द Doeberneir's law of triad, and this is the Newlands law of octave. These are the some examples, so watch it, and if you have any doubt then you can call me and wait for the next video. Okay, thank you, thanks a lot.